Good morning, everyone, from Brussels, live from the EIT house. Thank you very much for joining to this session. My name is Javier Gonzalez. I'm education developer at CLC West from EIT Manufacturing, and it's for me a pleasure to be the moderator of this session with all of you, with all these impressive and great projects that are working together in this innovation community, in this environment that we have and within EIT Manufacturing, where we want to make innovation happen, where we want to foster business creation, and where we want also to foster education at all levels within the countries where we are, and also in our communities. Our session this morning will focus on getting the results, the insights about the projects that are being developed during the year 2022 within our network, and it's for me a pleasure to be the moderator of this session. We will present different projects from different areas, from innovation, business creation, education, so that we can get those insights, those key results that will help to support the industry, research, technological organizations and universities in the manufacturing area in Europe, and will be also the contributing to ensure the competitiveness of the industry in Europe, and also to give solutions to the societal challenges that we will face in Europe in the next coming years. We have had a very interesting session this morning here at EIT House, as you maybe have already followed, about building innovation and skills in order to secure the energy and to optimize energy consumption in the industry for the future. And yeah, so the conclusions, the results, the comments from the project are very, very relevant, are very necessary in order to contribute to this collective objective that we have. So that's why we are here today. And what we would like to know is those insights and those contributions and those results from the projects that you are developing. And it's great to have you on board here today. And let's go directly to there. And let's start now with the first of the projects, with the Linuvas project. And here we have Yannick with us. So please, Yannick, the floor is yours, and we are looking forward to listening to your presentation. Thank you very much, Yannick. Go ahead.
My bad. Thank you, Javier. Thank you for the introduction. Yannick Rosemeyer from TU Darmstadt, Germany. I'm here as a representative of the project Linuvas, standing for Learning Nuggets for Worker Assistance Systems. Because what we're doing is create the knowledge or create the foundations of worker assistance systems for industrial companies, which is especially important in times of lot size 1 and ever-changing task descriptions. These assistance systems, either by physical, digital, or also in fact cognitive means, will help both shop floor managers and workers in better performing the task. So the goal of our project is to define a timeline or life cycle description, life cycle knowledge for worker assistance systems. So on the one hand, the shop floor managers will get to know the motivation, necessity, and also get a time, or not a timeline, but rather an order how to implement a first use case. In the meantime, we are also addressing workers who will later be users of the system. So the goal is also that they get to know what these systems look like and which are parts of the systems. If you are interested in the content, feel free to drop me an email. You can see my email address here below. Also, if you are familiar with one of the partners listed above at the right-hand corner, feel free also to contact one of the persons that you already know so far. So thank you for this short time, and Javier, I'm giving back to you.
Great, Yannick. Thank you very much for the presentation of the project. So as you already know, the fact sheets of the of everything, every project that we present today will be available for you. We're having this
Yeah,
information, basic information, details about the activities, and we are very thankful that you, Yannick, respected the time that you have already respected this the 4 minutes time for each one of the projects. So thanks a lot for these interesting projects. So wishing you all the best for the final phase of that, and
thank
looking
you.
forward to have to see the results in the
Yeah,
next coming months. Thank you
uh,
very much, Janet,
you're
for
welcome.
being with us today. Let's move now to the next project that we will present today, which is the winning project. So I'm looking here that we have with us for the winning project. Let me check quickly on my notes. We should have Sabrina here. Hello, Sabrina. Thank you very much for joining
Hello,
us
Javier.
today. Hello. So
Hello.
looking forward to listening to your presentation. So thank you very much. Floor is yours, please. Thank you.
Thank you for your introduction. So, hello everyone. I'm Sabrina Penels, a research engineer at the CA, a French Research Institute, and I'm going to be briefly presenting the winning project, which stands for Women in Manufacturing. So this project is also led with our other partners, SUPSI, a university in southern Switzerland, LMS, a laboratory in Patras in Greece, and the association Women in Tech, which is an association for women integrating technology for women. So the problem that the project addresses is the general issue of gender bias. So in the area of manufacturing, as this is still largely present, as it is still a largely male-dominated domain, but this is an issue that actually reaches other domains as well, technical and scientific, and it even starts early from the STEM education, as I'm sure you are all aware. So one of the solutions that the winning project proposes is to enhance female inclusion in the manufacturing industry through different such strategies, such as raising awareness about gender bias and including more female role models in education via interactive nuggets on the EIT Skills.move platform. And why is this important? Gender diversity has proven many benefits in terms of performance or in terms of balance in the working environment. And it is also important in relation to opportunities, equity of opportunities, regardless of the gender. So as you're well aware, this is an important societal problem that is present at all levels, from education to employment. And this is why, thanks to EIT, we were able to explore this societal issue and tackle it at the higher education level with the engaging and innovative mechanisms of the Skills.move platform. So the main results that we have achieved so far is the distribution of a questionnaire where we collected data about the different barriers that women and girls experience, both at the education level and during employment, for female inclusion. And the results were coherent with the literature, which that means that the barriers are still present, and they include, for instance, the presence of stereotypes and discrimination from teachers and peers, also the lack of role models and content that is more practical for female to gain their interest. And possible strategies as well, which are to include more role models and really raise awareness about the different biases. So we have developed interactive nuggets where we try to apply some of the strategies that we will evaluate with students and teachers. And this, if the results of this evaluation will lead to the proposition and refinement of some recommendations to enhance female inclusion in the manufacturing industry. Thank you. Oh, and if you want to ask any questions or contact me, so sorry, I haven't put the email, but we have a LinkedIn webpage for the winning project, so don't hesitate to drop a line there.
That's
Thank you.
fantastic, Sabrina. Thank you very much. Thanks a lot for the presentation. The very nice, very interesting insights on the project. So wishing you also all the best in this next coming months for getting the results. And yeah, as mentioned, if there is an interest, Sabrina and the team will be delighted to answer your questions today and afterwards as well. So thanks a lot, Sabrina, for being with us today. Nice day for you. And then we move to the next project in our session and in this breakout room is the Artom project, which will be presented by Gaetano Patrimia. So I think Gaetano is already connected. Hello, Gaetano. Thank you very much for being with us today. So please, the floor is yours. Looking forward to listening to your presentation. Thank you.
Yeah, hello, thank you very much. Hello, everyone. My name is Gaetano Patrimia from Prima Industria. We're based in Italy, and I'm the innovation and IP manager for Prima Industria. And I'm very pleased to present to you today the Artom project, where we are working with our machinery division, mainly dedicated for application on some panel benders machine that we produce. Inside with us in this project, we have also let's say the solution providers that are they are working on the solution, that are CASP and University of Patras with the LMS, and also the other end user that is Bazigos. The main problem and the main issue that we are addressing in this project, I think that is very well summarized in the pictures that you can see on the right, on the right, where basically we are working on some panel bending machine that are very manually machine, and that today there are still let's say some issue. As you can see, the operator are still working with, as you can see, with some paper on the machine to better, let's say, understand the phases and how to process the product. So let's say this project is very well focused on, let's say, on this metal sheet machine that are very manually, and where the operators, let's say, need to be very skilled and need a lot of support. So what we are trying to do in this project, which is our solution, it's basically an augmented reality-based application that is focused on supporting the operators during this during the multiple metal sheet machinery life cycle, namely operation, also training, and maintenance. The application basically is able to guide the operators during their shift train, them using digital content, and provide remote assistance in case there are some issue on the machine, there are some breakdown to the machine. This actually it's a continuation of another project, an European project called Manwork, and thanks to the EIT Manufacturing, now we were able to build this solution and to bring our idea to the next step, and to basically be ready with the product on the market. Why it's so important with this solution? Because basically now even with the operators with the less experience could start immediately to work on the machine. We drastically reduce the training timing, but also we avoid any type of error that could, of course, lead to some scrap on the production. And here you can see the main results that we are targeting. So basically, to increase the process quality at least for 30%, increase the operator performance by 10%, and decrease the let's say the repairing time from, let's say, 2 to 5 days that typically happen today, where we need to have an operator, our service operator, directly to the machine. We can maybe have a direct contact with our customer and try to solve the solution, try to solve the problem maybe in just few hours. And then, of course, eliminate a risk related to this machine that of course need to be. It's a very important aspect that have to be addressed on this type of machine. If you have any questions or other, if you want other information, of course, we are at your disposal.
Fantastic, Gaetano. Thanks a lot. So very interesting insight. So very nice project. So thank you very much. Hope that you can still working on the topic, and yeah, looking forward to getting the final results and having more news from your project. So So
Thank
go
you.
ahead and thank you very much for being with us today.
Thank you.
Let's now move to the next project. So I would like to remind you that you can put your questions in the chat as well, in case you have any questions, and we can read it at the end. And so as this is also available for you in case you want to make any questions about any specific project. Now let's move to the CMT for All projects, and I see that Johan Kildal from Techniker is already connected. Johan, thank you very much for being with us today.
Right, thank you very much for your introduction.
Floor is yours. So Johan, looking forward to listening to your presentation. Go ahead. Thank you.
Excellent. Thank you so much. So I'm going to be presenting the project CMT for All, which stands for Collaborative Manufacturing Tasks for All Workers. This is a project in which we are 3 technology providers, myself representing Techniker, and we're working with Grenoble University IMP in France and LMS from Patras in Greece. And there are 3 end users in the same 3 countries. We've got Alpha in Spain, we've got ADTB in France, and Kleman in Greece. And here's the motivation for the work. So in the Universal Declaration of Human Rights, in its Article 23, you can read that every person in society has the right to access a satisfactory job. And by every person, we mean workers with every kind of profile. That will include regular workforce, but also workers with aging, advancement of variation of profile, different skills, and persons with disabilities as well, including physical, intellectual, and sensorial of every kind. And everybody's got the same right to get their satisfactory job in industry. So how to tackle this? It turns out that actually something needs to be done because in industrial jobs, typically requirements of profiles are very specific. So what the path we're taking here is to combine new collaborative technologies that are mature enough to be able to integrate them following design for all principles. And the technologies we're working with are collaborative robots, augmented reality, machine vision with artificial intelligence, and also natural user interfaces. And with all of that together, we've created a modular workstation that can respond to needs of different workers and different processes. So in the project, we have created 3 instances of the workstation with 3 real scenarios in which we have tackled ergonomics challenges. We have created paths for leading the worker step by step in the job, so that that becomes much easier. We are checking for errors that workers may be executing as they go advancing in the production, and we have created means for indicating to the worker that the collaborative workstation is safe, and actually to make it safe. So that helps with acceptance of technology at work. The social impact of this project is quite significant. It supports social sustainability. It reduces skills barrier for accessing to jobs. And it proves that user-centered integration of new technologies is a very powerful approach to support employability of workers when new technologies arrive to manufacturing environments. As an immediate and final conclusion and consequence, we obtain better work conditions, and we lead to better quality of production as well for the companies.
That's great.
Thank you very much,
Johan. That's fantastic. Thank you also for being on time. So with the 4 minutes that we have allocated for it. So that's great, and thank you very much for giving us this insights from the project. So we wish you all the best in the next coming months as well, for having better results, good results, and we're looking forward to getting those news from your side. Okay, so thank you very much, Johan, for being with us today. Now let's move to the next project, the project Digilit, and we have Lina Jidereite from Limpra here with us today. So Lina, hello, thank you very much.
Hello, everyone.
Hi, Lina. The floor is yours. Thank you.
I am Lina Jidereite, and I represent the Lithuanian Engineering and Technology Industry Association Limpra from Lithuania. And today I want to present your project, Digital Literacy Enabling Workforce for Industry 4.0 Digilit. So digitalization and automation are among the key drivers for the transformation of the manufacturing industry. And to successfully transition to the digital age, manufacturing companies need smart workers with the right skills. Most industrial workers today have a wide range of manufacturing and technological skills, but digital skills such as computer thinking and coding are increasingly scarce. So a consortium of partners, Limpra, Kaunas University of Technology, Festa Didaktik, Fraunhofer, and Technische Universität Wien is implementing this project aiming to improve digital skills of industrial workers in the manufacturing sector. The project partners are developing training program that will include digital skills, topics such as coding, algorithmic thinking, sensor data integration, machine vision, data processing, and others. And the project aims to develop training to address the digital skills gap in the manufacturing industry. And the proposed training program is aimed at professionals in manufacturing who have extensive practical knowledge but need to develop their digital skills. And the training will be based on a project-based thinking approach and a gender-equal practical didactic approach tailored to the needs of working professionals. And to maximize the learning experience, the training will combine two recognized learning platforms, Robotino and Nepo. So as you can see, this project is related to the digitalization of industrial companies, and while upskilled workers and engineers from industry contributing to closing the skills gap and increasing productivity and competitiveness in manufacturing sector. So skilled workers can be a bridge for a company to move into the digital age. So thanks to EIT Manufacturing, we will be able to reduce the knowledge gaps of workers in manufacturing companies and help them to keep in line with the newest stages of Industry 4.0. Thank you for your attention.
That's great. Thank you very much, Lina, for this insight. So very, very interesting action. And as mentioned to all of you, to all the projects, we are really very thankful to you. We're very thankful to all the projects that are collaborating, and also we are very happy to support you on achieving those results. And we're looking forward to getting all the results and all the inputs from your side. That's great. And so thanks a lot, Lina, for being with us today, and looking forward to getting more news from your projects. Okay, thank you. Thanks a lot. Next project in our breakout room today. So we are getting very nice insights this morning, and it's really interesting. And we have more interesting insights to come. The next one is ERA from Comau, and I see that Francesco is connected. Francesco Beccarisi from Comau. Hello, Francesco.
Hello.
Please, floor is yours. Looking forward to listening to your presentation. Thank you.
Good afternoon. So let me introduce myself. I'm Francesco Beccarisi, and I work in the Advanced Robotics and Digital Solution Department. I'm Innovation Manager. I'm here to present the project that is called ERA, so Energy, Renewables and Automation, and it's Robotics for Sustainability. The project is the result of a collaboration between Comau and Enel Green Power that was expanding then to Soltec and Comal, that are two of the suppliers of Enel Green Power. And then we also have a strong collaboration with the University of Applied Science of Switzerland, where we are collaborating with multiple projects. So the problem that we had to tackle was the installation of solar trackers, including the solar tracker structure and the modules. The objective of Enel, Soltec, and Comal as an end user was, first of all, to reduce the installation time, but granting a higher quality and a better working condition, and reduce the heavy loads and wearing operations for the operators. So even if the robots that are involved are not collaborative, the operators and the robots are collaborating in this station, since the robot is doing the operation with low value added activities, and the operators are doing screwing, riveting, that are high value added activities and requires precision and flexibility. The solution that we proposed is mainly composed by two parts. The first part is a mobile temporary factory. As the energy plants are changing from time to time, the factory has to move from one plant to another. In this temporary factory, we do pre-assemble the tracker structure with the modules that are then shipped with the second part of the solution, that is a rover that is specifically designed to carry this huge structure. We are talking about structure that have a dimension of 12 meter by 5 meter, just to give you an order of magnitude. We have very strong impacts for society for multiple reasons. First of all, we are changing the paradigm of the installation, helping operators working in the construction. And second, we are enabling the widespread of the photovoltaic energy transition and the deployment of new plants with a robotized solution that today is out of anybody's control. The EIT was helping us in putting together all these partners, technological partners, as well as potential customers, all around the same table, but at the same time to introduce a solution that is disruptive for a certain sector, the photovoltaic sector, because it's changing the paradigm from construction to manufacturing. Main results are, for sure, the fact that we are testing the solution in a real full-scale environment. We did perform a human job quality assessment, and we are ready for the go-to-market. So by the end of the year, we will be ready to launch this product in the market and probably to collaborate with these companies. So that's it from my side. I hope everything was clear. My contact is in the fact sheet. I will be more than happy to receive questions later.
Fantastic, Francesco. Thank you very much for the presentation. The really amazing initiative, and yeah, wishing you all the best in the next steps, and looking forward for getting more and more results and inputs from and outcomes from your project. And yeah, thank you very much.
Thank you very much
for being today. Thanks a lot. Thanks a lot, Francesco. Let's go for the next one, the next project that we want to listen to today about the results. And it's one project where we are also taking part as EIT Manufacturing. It's the EU Project. And for this, we have our EIT Manufacturing colleague, Maxime Momerenzi. Hello, Maxime. Nice to see you. Thank you very much for being with us today. And we are looking forward to listening to you and the insights from the project. So, floor is yours. Thank you.
Gracias, Javier. So also from my side, thank you for joining either in Brussels or online. My name is Maxime Momerenzi. I'm a project communication manager at EIT Manufacturing East, and I'm happy to share some details about the Breakout project with you today, which is, as already mentioned, a strategic project in which EIT Manufacturing participates. So a little bit of context. Breakout stands for the European Production Giganet, and is a bilateral Austrian-German project which started in March 2021 and runs for 4 years. EIT Manufacturing Central East are part of a consortium of 16 partners. This project is the Gaia-X Lighthouse Projects for Industry 4.0 and aims to make manufacturing ecosystems more resilient in the face of supply chain disruptions. Think of pandemics or wars. Now, for those who don't know Gaia-X, a little bit of background. Gaia-X is Europe's cloud infrastructure, which is based on the principles of sovereignty, security, and transparency. Now, why are these principles important? Well, if you want to share data today, this data is copied and basically given to someone else. This, of course, is not sovereign, not secure, and not transparent. Gaia-X aims to solve these problems because Gaia-X is designed to make a decentralized ecosystem possible. This means that when one node of this ecosystem fails, the ecosystem keeps functioning. And this means a more resilient ecosystem. Such ecosystems enable data-driven business models for companies, where manufacturing companies can securely offer their data and algorithms for sale and decide for themselves which data they want to share and which not. So Breakout is implementing these principles in manufacturing to ensure a more sovereign, secure, and more resilient manufacturing ecosystem. So what was achieved in the first 1.5 years? Well, first, we built a fully functional demonstrator. We linked a CNC machine to the Gaia-X infrastructure. 2, we built a functioning portal which acts as a kind of marketplace linked to the federated catalog on which data and algorithms can be offered and sold. You can access this portal through the Breakout website. 3, we have implemented a Delta DAO technology stack based on Web3 technology combined with Breakout edge nodes. And 4, we are compliant with the current Gaia-X Trust Framework principles. Now, what is next for Breakout? Well, further European and nationally funded projects tackling similar topics are becoming part of the Breakout ecosystem, which means there's a broad range that we can cover. We are currently developing a network called Gen X, which is based on the principle owned by no one, open to everyone. And the first companies are being onboarded and integrated into the network as we speak. If you would like to learn more, just visit our website, breakout.com/en for the English version, and make sure to check out the Experience Gaia-X site for more information and access to the Breakout portal. Follow our updates on social media, or feel absolutely free to reach out per email. Our contact details are on the fact sheet. Very happy to answer any questions after this session. Thank you very much.
Thanks a lot, Maxime, for a great introduction, great presentation of the project. As mentioned, wishing you all the best in the next steps on the project. We will be listening to and looking forward to getting news and insights from the social networks and the activities that you do. Will be really great to have you in future editions. So thanks a lot for being with us today, and looking forward to getting more news from your project.
Thank you.
Okay, thank you very much for being with us. Let's move now to the next project, the FlexBD project from Comau, and I see Vito Borrelli already connected. Hello, Vito. Thank you very much for being with us today. So please, the floor is yours, and looking forward to listening to your presentation. Thank you.
Thank you. So my name is Vito Borrelli. I'm an advanced system integration specialist in Comau, one of the industry that are part of the FlexBD consortium, together with Norsk Hydro and Evian, that are the two end user, Festo and University of Applied Sciences and Art of the Southern Switzerland, called SUPSI. FlexBD, which stands for Flexible Battery Dismantling, would not exist without the push of the European community to electrification, and therefore the creation of battery regulation, which dictates the quantity of material that must be recycled and the method for recycling it. The new requirement, together with the huge volume growth of the electric vehicles, I'm talking about 400% growth in 8 years with an exponential trend, asks for a significant increase in the industrial battery recycling capacity. Operations that today are done manually and therefore are unable to follow the market requirements. The human-based disassembly also exposes human operators to dangerous chemical and high-voltage devices, demand for dual and repetitive tasks with heavy loads. Let's talk about what we did and how we did it. Starting from the end-user needs, we designed a flexible automated solution that allows disassembling of various battery packs to improve the quality of the recycling operation. It enables maximum value creation from every battery pack through identifying and reusing, obviously where it's possible, the battery modules. The solution unscrew, cut, pull, detach, tear the battery pack in order to automatically separate the various components that form the battery, including the modules that are the most valuable part of it. The separated component will be recycled. This is usually true for like metal covers, base frame, copper cables, or faulty modules, or can be reused in second life application. The three main pillars that we used to engineering the solution were reusability, reconfigurability, and modularity that were applied in both hardware and software. The software platform, that is the core of the system, is able to manage the abstraction layer that, based on advanced 3D imaging, enables the load code programming approach and the redefinition of the working cycle over different battery pack models. The robot is moved automatically through robot guidance and collision avoidance, but through what we call the point of interest that automatically created the dynamic path planning of the machine. I will also say that FlexBD is not programmed using the classical low-level programming languages, but instead used high-level languages that permit the cell to be reprogrammed in a matter of hours by a non-skilled operator just selecting the right action and the point of action on a graphical user interface. I think that my time is over. If there are any question or curiosity, please feel free to ask here or contact me at the email address that is vito.borrelli@comau.com.
Thank you very much, Vito, for the presentation. Really great and very nice results that you're getting with the project. And yeah, as mentioned, so very thankful that you are also participating in the EIT manufacturing initiatives, and for us a pleasure to support you and support all the projects that we have today in this breakout room. So thank you very much for the work, Vito. Looking forward to getting more insights and more results from your project soon. Okay, thanks a lot. Let's move now to the next project, the Flexbot NDT project. It's coordinated by LMS, and if I'm not wrong, it's Fotios Stamatopoulos, which is presenting today. It's that right, Fotios? You presenting the project, right?
Sorry, I'm from DevNoNet, so somebody else is probably presenting that one you just mentioned.
Okay. So
this is George Michalos. Hi, nice to meet you.
Oh, George, are you presenting? Okay. I'm mistaking my notes here, so sorry for that, but you will be the one presenting. Thank you very much, George, for being with us today. So please go ahead, and looking forward to listening to you. Thank you.
Okay. Thank you very much. Hello, everyone. My name is Dr. George Michalos. I come from the Laboratory for Manufacturing Systems and Automation. My expertise is in industrial robotics and human-robot collaboration, and this is why also this has been a particularly interesting project for me. It is called Flexbot NDT. It involves 5 partners: LMS, Best Alpine, Joanneum Research, Ondosense, and Awesome Technologies. So these are technology companies. The main focus here has been to try and automate a job that is traditionally manual. The reason behind it is not that it requires a lot of dexterity, because there have been ways of performing the manual job using templates and guidelines. So it is a work that can actually be done, but it takes a lot of time. It is quite monotonous, and it really is not really the scanning process for scanning of metal plates is not really value adding. What has been actually the problem here that we wanted to address is the fact that experts in NDT, these are people that have the training and the knowledge and also the experience, because this is also a very important factor. All those people who have the experience to analyze data that are being collected from the NDT process, these are usually people that have a lot of a high cost because of their training and qualifications. So it really makes sense to use this kind of people in the data interpretation and not in the data acquisition, in the scanning of these large plates. So with this project, we had the chance via EIT Manufacturing to bring together these 4 companies that had exactly the right amount of competencies and the correct type of competencies. So what we have come up is an installation with an overhead robot like the one you see in this image just behind the EIT logo, that allows the operator to very quickly program the system. So just by moving the robot in some arbitrary points that the operator chooses over the plate to be scanned, it generates the scanning plane, it generates the trajectory that has to be performed. The trajectory has to be very well defined so that it covers the complete plate, and we have 100% quality inspection of the plate. And as soon as the operator does this teaching process, he or she is able to walk away, let the robot continue the scanning, and then come back and ask the robot to pinpoint the areas where some anomalies in the structure of the metal plates have been identified. So for this process, we have already, together with our colleagues, we have created a robotic end effector that is able to carry the ultrasound sensor, to also apply coupling media, either if it is based on oil or water. And then it can be very easily taught by the operator on what is the area that it needs to scan. So for us, and also for the end users, it is one of the directly exploitable projects, because now we are in the process of testing, of doing the final testing and integration on their premises. We expect it to be done within December. And we hope that it will be a ready solution that can very easily apply in more than one companies that are interested in doing this ultrasound inspection. So these are the highlights from my side, and just to stay on time, I would be happy to answer any other questions that you can send me via chat or email. Thank you very much.
That's great, George. Thank you very much. Really interesting, very amazing, really interesting insights from the project, and yeah, looking forward to getting more insights, more results, and yeah, I'm very happy to have you working on this in the EIT manufacturing community. It's really a pleasure. Thank you very much for being with us today. Let's move to so we are around half of the session, and we now go for listening one of the projects that we are doing from the education pillar from EIT Manufacturing, the HEY initiative, where we are collaborating. And it's my pleasure to introduce my colleague, Monica Blodgett. Hello, Monica. Good afternoon. Thanks for being with us today. And we are really looking forward to listening about the HEY initiative and what's this about. So please, Monica, go ahead. Thank you.
Thank you, Javier, and thank you for your excellent moderation, as always. I am Monica Blodgett. I'm the program manager for EIT Manufacturing on EIT's HEI initiative, which is a cross-kick initiative that involves all of the 8 kicks and soon to be the 9th kick of culture and creativity. The HEI initiative stands for the Higher Education Institutions Initiative, and it was designed to address the problem of higher education institutions across Europe sometimes having low innovation and entrepreneurial capacities. So in the strategic innovation agenda set forth for 2021-2027, the idea is to improve the innovation and entrepreneurial capacities of the higher education institutions across Europe so that they can become engines of change, so that they can have also better integration into the knowledge triangle. So that's between business, research, and of course, higher education institutions. So with the HEI initiative, we have 49 projects, and each of those projects on average consist of around 6 to 8 partners of mainly higher education institutions, where they execute an innovation vision action plan to improve again the innovation and entrepreneurial capacities. This is really important for society and set out as a main goal of the strategic innovation agenda, because the idea is that higher education institutions will be the drivers of innovation and entrepreneurship in Europe and inspire solutions to address the societal issues, especially in regard to carbon neutral, digital, circular, and inclusive society. We have already gone 2 cohorts of the HEI initiative, and we've recently launched a 3rd call for proposals, where we will be awarding each awarded project up to 750,000 euros. And we're really looking forward to seeing continued results of the HEI initiative and all of the great works of the project. In the fact sheet, you can find the contact information as well as the social media to follow news and updates. And I encourage everyone to explore the call 3 for proposals, which is now live. Thank you.
Thanks a lot, Monica, for the great presentation and the introduction and these key facts about the initiative. As you mentioned, the 3rd call for proposals is open this year, focusing on deep tech. So it's deep tech concept will be around us in many initiatives. So we encourage all of you, all our participants also to take a look at the call text and on our website, and also the HEI Initiative website, and looking forward to having your projects and your proposals in this next call. Thanks a lot, Monica, for the insights, and looking forward to getting more news about the project soon. Thank you very much. Okay, now let's move to the next project, InMass project, coordinated by Stuba, and we have today Stefan Hiczak presenting this initiative. I think, sorry if I don't pronounce the names correctly. I'm trying to do it in each one of the languages.
You did it just perfectly.
Perfect. I'm very happy. Thank you very much. So just apologize if I could make some mistakes. So, okay. I will try. So thanks a lot. So please, Stefan, floor is yours. Looking forward to listening to you. Thank you.
So hi all. My name is Stefan Hiczak. I'm working as a project manager at the Slovak University of Technology in Bratislava. Thank you very much for the chance to be here and present our RIS activity InMass in a full name, Interactive Manufacturing at Schools. All of you know that there is a need to increase the numbers of people studying STEAM and working in manufacturing. I'm going to tell you our story and how we implemented it. We have started with the InMass activity in 2020, and for 2022 we continued with our hubs as the place or platform through which we further develop cooperation with high schools to enhance interest of pupils in studying STEAM and manufacturing related fields. These hubs focus on providing hands-on learning experience in topics like Lego robotics, additive manufacturing, and manufacturing systems. And during 2022, we created 7 learning nuggets as our digital content, and now we are starting to have them consumed. For me personally, it was not an easy task to manage it all, but on the other hand, it was really interesting and nice to see a lot of enthusiastic young people, and also compare the experiences and maybe bottlenecks of STEAM education or ICT studies, and also approaches to popularization of manufacturing in our countries. As you probably know, projects are evolving up on the time. So for 2022 activity, we added one new partial activity. We decided to conduct the research through survey in selected manufacturing companies. Research was focused on identification of issues or barriers to which manufacturing companies from our countries are facing. Partially it was focused on research on future skills of youth and also level of digital transformation in the manufacturing companies in our countries. 32 manufacturing companies employing more than 7,000 employees joined this research, and now we are in a phase of analyzing answers and preparing a report on this research and data analysis. We will finalize it until probably end of this month. So if someone is interested, feel free to drop me an email. Regarding the EIT manufacturing support, EIT manufacturing supported us, especially in the creation of these learning materials to run the workshops and help us with the needed infrastructures to build nice hubs and supports the understanding of impact that manufacturing can deliver. Our consortium consists of 3 universities: Slovak University of Technology in Bratislava from Slovakia, then University of Tartu from Estonia. I want to greet my friend from the project, Ramon, and also a Greek partner, laboratory for manufacturing systems and automation from University of Patras. For a 2022 activity, INMAS joined also one non-profit organization, European Knowledge Economic Pass, with a seat in Slovakia. And during 2022, overall, we realized a lot of different activities and prepared, I would say, robust framework for the sustainable work in the future. And although we were not awarded to continue with the activity in 2023, we plan to involve more industrial partners in our activities and put our efforts towards the support of innovation and entrepreneurial agenda. Regarding some operational steps, we would like to improve also our visibility and user management. And now I'm at the end, so I want to thank you, my INMAS colleagues, for their work and also contribution. And thank you very much for your attention.
That's great, Stefan. So thank you very much for the insights. Looking forward to getting more and more results from the project, and wishing you all the best in the next implementation phases, and to you and all the consortia that I know that they're working very good on this initiative. Thanks a lot for being with us today, and looking forward to getting more news from your project soon. Okay, let's now move to the next project on our session, the Intex project, coordinated by Tecnalia. And today we have with us Leire Martinez. This name I can't pronounce it good. It's my mother tongue. So I think, thank you, Leire, for being with us today. So looking forward to listening to you. Go ahead. Thank you.
Thank you very much. So hi everyone, my name is Leire Martinez, and I would like to give you some details of the Intex business opportunity. So exoskeletons have shown that they could provide benefit in certain tasks, in the sense that they can try to lower the workers suffering from musculoskeletal disorders, because they can reduce the risks associated to repetitive stress or the risks associated to heavy loads. They can also be of use for those aging workers so that they can continue to perform activities for longer. However, when we have talked to industries, those that knew about exoskeletons and that had tried, they told us that they bought 2 or 3 units, they played around a little bit with those, and then they did an assessment that was very subjective, asking workers how they felt, if they were comfortable, if they liked it, and some of them did an ergonomy analysis. This assessment has proven not to be enough to be able to make decisions on big investments that would be needed to be able to equip all workers that could benefit from an exoskeleton. So what we are offering in Intex is this objective assessment. And we do so through algorithms that we are able to calculate different concepts, different performance indicators, such as the metabolic cost, the cardiovascular effort, or muscle fatigue. And through the comparison of these performance indicators, industries are able to have objective data and to be able to decide what is the benefit that the exoskeleton is bringing. So to do so, we use the structures that you can see in the pictures in the fact sheet. These are flexible structures that are modifiable and that we use to recreate the real-life workplace of our clients. As you can see there, we have a staircase simulated, a worker working overhead. And then on the top left, you can see someone on a confined space, right, on a tight space. So what we do is we do the evaluation with and without exoskeleton or with several exoskeletons, and we are able to provide this objective data to the clients so that they can make their own decisions. When we do this assessment, we do it from a global perspective, and we do it from a global perspective in two different senses. One of them is that we don't focus our evaluation only on the execution of the specific task that the exoskeleton was designed to assist, but we also assessed how the exoskeleton behaves around all the secondary tasks associated to the work cycle of that worker, so that we can make sure, for example, that the exoskeleton is not impeding movement in other tasks. And the second way that we have this holistic approach is that our focus is not only set while the task execution happens, but we also take into account what is the impact, what happens in the rest and recovery phase. For example, how fast a worker can recover using an exoskeleton, after using an exoskeleton, or after not using an exoskeleton. We provide three different services that you can see there. The index benchmarking services, which is directed to exoskeleton providers, distributors, and manufacturers, so they can decide whether their exoskeleton is good enough for the tasks that they want, or whether it has, which are the strength points or the weaknesses, so that they can work on those if they would like to. And then we have the Index Exo Matchmaker service, which is directed to user ends, to the industries, so that they can answer this nagging question that they carry about which is the exoskeleton that I need to buy, which one will bring me more benefit. And then we have the training service that is based on the learning nuggets, and it will allow you to get most of your exo investment. So
Great.
Thank you.
Thanks a lot, Leire, for this introduction. Very interesting projects, and very much aligned to the, as all the projects, of course, very much aligned to the strategic agenda of EIT Manufacturing and all the challenges that we have here. So you have this document available online, and you have already maybe this document as well in your company. So just take a look at that. It's very relevant what we have here, and it's very nice to see how the projects are aligned with this strategic agenda of the EIT Manufacturing and their priorities. So thank you very much, Leire, for the presentation. Looking forward to getting more results from your project now. Let's move to the next one. So the Kybiotics project, coordinated by Aerospace Valley, and I think it's Cyril Tual presenting today the project. Hello, Cyril. Thank you very much.
Hello, thank you, Javier. Hello, everyone.
Thanks a lot.
Glad to
Thanks
be
a lot.
here.
So please go ahead. Floor is yours. Looking forward to listening to you.
Thank you. So hello, everyone. So I'm Cyril, from project manager from Aerospace Valley, a French aeronautics and aerospace cluster located in Bordeaux and Toulouse. I will talk about our Kybiotics project, which aims to decrease the penability of work by discharging the operator from repetitive tasks. The idea is to use collaborative robotics for that. And we are here focusing especially on complex surface finishing operations, such as deburring and polishing on different types of parts. And so our solution, what is it? So first, it is to use cobotics as a facilitating tool for these operations. And yeah, the concept is to develop a specific tool for each operation, which we call the end effector. And yeah, so this is basically the tool, like the manual tool, put and adapt to the cobot for each operations, and it's enabled the cobot to adapt to every situations we are facing. So then the operator can focus on his action to control and guide the cobot. And yeah, the machine and the human takes benefits of each other, and that leads to, of course, improvement of productivity, but also improvement of quality of work. And so yeah, here IO Space Valley, we act as a project coordinator in our consortium. So we have 2 technology provider and integrators, EasyBoat in France and Amatec in Austria. And we are also working with 1 RTO, CA in France, which focused on the validation at lab scale, and of course the development of the prototype. And so for first testing of these solutions, we have two first use cases. So one in France with Lizzie for polishing operations on complex titanium parts, which has been validated at the real scale just now. And we are currently evaluating the second use case, the voestalpine one for grinding and deburring operations on small metallic parts until December. And yeah, in terms of outcomes here, of course, we are talking about improving the productivity, but the thing to have in mind also is that we want to participate in this, achieving this social sustainable manufacturing, because of course, as I said, we try to improve quality of work, and while we are improving productivity. And that leads to empowering the workers instead of replacing the worker. And of course, the other outcome we can highlight here is that we manage to restore the manual job and also the manufacturing industry's attractiveness, because you are not anymore like people that are working on barefoot tasks. You are like an expert in how to act with the cobots, and you really become an expert on your operations on these complex parts.
Great.
And yeah, I think that's all for me. Thank you very much. I think you have my email on the presentation if you have more questions, or if you want to know more about the project. I would be really happy to answer you, of course.
Fantastic, Cyril. That's great. Thank you very much for the presentation. Thank you very much for the details, the comments, and the insights and about the project. And so, really looking forward to getting more news, more insights, more outcomes from this interesting activity of K-Biotics. And wishing you all the best in the next steps of the implementation. Okay. Thank you very much, Cyril, for being with us today. That's great. Let's move to the next one. So learn for SMEs. So project focus on SMEs, and this project is coordinated by TUVIN, but today representing the project we have Bojan Jovanovski, which will be presenting the initiative. Bojan, hello. Thank you very much for being with us today, and looking forward to listening to the presentation and getting details from the project. Thank you very much. Floor is yours.
Thank you very much. I hope you can hear me. So I'm representing the Learn for SMEs project. My name is Bojan Jovanovski. I'm coming from CIRCO, company based by the Faculty of Mechanical Engineering. And this project is run by TUVIN. And the other additional partner in the project is the Festo Learning Center. Additional to that, we have additional 6 associated industry partners, local ones, and 2 international academic partners, which are the Faculty of Technical Sciences from Novi Sad, Serbia, and the Technical University of Sofia. Learn for SMEs stands for a learning factory for improving digital competitiveness and Industry 4.0 readiness of the SMEs in the Balkan region. What is the problem that we wanted to tackle in the very beginning? So obviously in this part of Europe, the skill gap regarding the digital technologies is pretty obvious. And the idea how to tackle this is the developing the learning factor. So this was the idea of the Theo Wien, who have a lot of experience regarding this. And this idea about developing a learning factor in our country has been here in our department, in our company for more than 20 years. Thanks to EIT Manufacturing, it has come to alive with this project, and we are really happy that we are moving forward with this. So this was the module how we're going to tackle this problem. Then we said, what are we going to offer in this learning factory? That's why we did a survey with this focus group of industry partners and academic partners regarding what should be the topics that this learning factory should address. And throughout this workshop and throughout one survey that we developed, Lean and Industry 4.0 were one of the biggest areas that were interested for the companies. And that's why we developed Lean Manufacturing 4.0 Lean Path, learning path that was created and published on the Skills.move platform. But then we decided that it should not be only theoretical, we should develop also a showcase about it. So we also developed a showcase, and in this beginning, at this early stage of the project, we developed one showcase using one module of the whole learning path, which is the smart Pokayoke system. So we are living in a period where the supply chain is really tough on us, and it complicates the things for developing this whole learning factory. That's why more modules will arrive in the end of this year, and we hope that we will complete the whole idea and the whole concept about how a learning factory should look like at the very beginning. As I said, we use the blended training program on Lean Manufacturing 4.0, and I'm really happy to announce that last week we had a workshop with over 40 participants in North Macedonia, in Skopje, and the feedback that we got was really tremendous. They were really positive about this innovative and novel way of learning about the Pokayoke system. And throughout our partners in Bulgaria and in Serbia, we plan to enrich the effect of the learning factory. And hopefully we can also develop new learning factories in our partners so that we can further enrich the network of learning factories and develop new ideas and new projects together with them.
Fantastic.
Thank you very much for the time. And if you have any questions, I'm here to answer them, of course.
Thanks a lot, Bojan, for the presentation. Really, very much on time. So I also want to thank you to all the speakers for respecting the time of 4 minutes. It's working very, very good. So thanks a lot, and thank you for the insights and the outcomes and the results that you've mentioned for the project. Looking forward to getting more and more results and more information from the project. So the fact sheet is there. Contact with you, it's also there. So very, very thankful for your collaboration and for your projects, and wishing you all the best in the next steps for the implementation. Thanks a lot, Bojan, for being with us today. Let's move now to the next project. So we are reaching the final one. So last but not least, but these are the next 5 projects that we have in our session today. The Mars projects coordinated by FIB Group, and we have the pleasure of having Lorenzo Quirego here with us this afternoon. Lorenzo, hello. Thank you very much for being with us. Looking forward to listening to you. Thanks a lot.
Good afternoon, everybody. I'm Lorenzo Quirego. I'm the CTO of FIB Intralogistic Italy. And we are a company specialized in building and designing sorting systems, so intralogistic systems. And together with SIC, BIBA, and LMS, we developed a new indoor intralogistic solution called Mars. Mars is a solution based on mobile robots. And mobile robots today, you can find on the market 2 categories of mobile robots. One is collaborative robots that have to move following safety regulations to avoid, safety problems with people they work with. So they are very flexible, but they are also not so much performing since they need to go slow and keep some distances. Then you have the other category is, let's say, confined robots that work in a cage. Working in a cage allows them to go very fast, to forget about safety distances. So they're very effective, but they're still limited by the cage. So there are some cases where you want both of, you want, high throughput, but flexibility. And to answer this request in intralogistics, we developed this mobile robot solution that can behave in both ways. So can behave as a collaborative mobile robot when working, let's say, together with people, but can switch off all safety protections and go at maximum speed when it goes inside of the cage and the passage is done without stopping. So it's just seamless. We made the prototype test in March this year, and it was successful. Now we are in the final safety certification paperwork phase, and we are almost ready to go on the first real installation. If you have any,
thank you very much. Thank you very much, Lorenzo.
Question, you can contact me.
Of course, thanks a lot. So, very, very, very thankful for the presentation, and very interesting, good insights from your project. So, as mentioned, there's the option of putting your questions in the chat box. So please use that in case you have any questions for any of our speakers this afternoon. So thank you very much again, Lorenzo, for the presentation, and looking forward to getting more results and insights from your project soon. So thanks a lot for your participation in this session. Let's go now for the next project, the ROS for Dev project, which is coordinated by Paris Tech and Sam. And we have the pleasure of having here Leopold Boyard. Hello, Leopold. Thanks for being with us this afternoon, and looking forward to listening to your presentation and the insights from ROS for Dev project. So the floor is yours. Please go ahead. Thank you.
Thank you, Javier, and thank you, everyone. So I wanted to talk about the ROS for Dev project, which is an education project. So the target of the ROS for Dev project is to try to increase the knowledge that exists on ROS solutions. So in particular, when we think about the fact that nearly 55% of commercial robots that will be shipped in the next 2 years will have at least one ROS package installed, we can see how much it is necessary for anyone who is in direct contact with us to develop their knowledge on ROS. So we decided as a consortium to build on the knowledge that we already developed in the previous project that was similar to this one, called EROS for Pro, that were targeted at professional, and to narrow a bit the subject and the target group to developers in particular. So the consortium is, as you said, led by Arts et Métiers. So I am the project manager at Arts et Métiers, a French university. And we also have one RTO during research. We have another university, the University of Tartu, and we have one SME in Spain, Alias Robotics. So in order to try to increase the knowledge on ROS specifically for developers, we went through two different ways, let's say on two different legs. So the first one is to try to have a general sharing of knowledge through skills.move and through this opportunity that we have to go through this platform to reach as many people as possible. So for this, we developed 27 different nuggets along 5 learning paths. So the first one, securing ROS applications, auditing ROS applications, building ROS security awareness, ROS continuous delivery, and building a simulated grasping application with machine learning in Coppola Sim. So building on these 5 learning paths, we also decided to go one step further in order to have hands-on trainings to actually tackle issues that were facing SMEs and that were facing companies on concrete problems. And so there are 3 different hands-on trainings which are currently taking place. One already took place in Estonia, there will be another one in Spain, and there will be a last one in Austria. So the goal is really to have those learners, first of all, integrate the knowledge that we provide for them through the learning paths, and then second of all, we come up with their own problems, and so that we can help them for a day or a day and a half into going one step further in solving all the ROS problems that they may have, and providing them with the actual ROS solutions. So you can contact me, of course, if you're interested in knowing more about this project, learning more about this project, and if you're interested in joining for the trainings as well. Thank you very much.
That's fantastic, Leopold. Thank you very much for the insights. And in fact, I had the opportunity of see the project really running in in one event, and it's really interesting and very nice the work that you are doing with the project. Thanks a lot. Looking forward for getting more and more results. So congratulations to all the teams, to all the projects that we have here for the good results and the good work that you are doing. And as mentioned, very happy that you are collaborating with EIT Manufacturing, and EIT Manufacturing is collaborating with you for making this project a reality. Thanks a lot, Leopold, and see you soon. Thank you very much. Now let's move for the next one, the Shaping Project. Shaping Projects coordinated by the University of Porto. But I think that today is Xavier Uriarte from Tecnalia presenting the initiative. Hello, Xavier.
Hello, good morning.
Hello, thank you.
Thank you very much for the opportunity.
Please, yeah, the floor is yours. We're looking forward to listening to you. Thank you.
Okay, thank you. So I'm going to present the Shaping project. Shaping is just the short title of the project, because the long one should be Shaping the Next Generation of Manufacturing Professionals, which is quite an ambitious title, quite an ambitious objective, as you can see. It's coordinated by the University of Porto, but besides, along with them, we are participating other four universities and Tecnalia. The University of Patras, the Czech Technical University in Prague, the Slovak University of Technology in Bratislava, and also the University of Tartu in Estonia. Okay. So we know that the why, let's say, the problem of that Shaping is trying to solve technologies, we know that are transforming some repetitive jobs that are into others that require more specific skills today, such as leadership or problem-solving skills. And we also know that the number of scientific and technological vocations is declining in Europe, especially among women. And this implies a great labor shortage problem for the manufacturing sector. So as manufacturing is on the forefront of this change, we think that it's critical to raise awareness among young students, and especially girls, that we see that are underrepresented in this sector, on the opportunities that the sector offers to them. Okay, and the new skills that they need to navigate, let's say, in Industry 4.0 or the fourth industrial revolution. We are targeting now students aged between 12 years old and 18 years old. Okay, and the solution that we have put on the table is developing a network of smart manufacturing demonstrators. Some of them are based on technologies such as additive manufacturing. This is 3D printing, robotic arms. Others are projects that we are currently working on. And together with videos and presentations, we try to attract, let's say, young students to the world of manufacturing, okay, to the manufacturing industry. Yeah, it's quite an ambitious, as I said before, it's quite an ambitious project in this sense. So the goal of the project of Shaping is motivating and raising the interest of young European students for activities in the field of manufacturing within 6 EIT-rich countries: Portugal, Spain, Greece, Slovakia, Czech Republic, and Estonia. Okay. So why do we think that this project may be important, this initiative may be important for society? Well, we think that encouraging students to pursue a career in manufacturing is quite a strategic societal concern. And the relevance of this is related to some elements such as this that I'm going to explain, to describe. I would say that the first of them is to ensure an available and well-qualified future workforce for the manufacturing world. Okay, they have to be capable of dealing with the fourth industrial revolution challenges. Then we also would like to reduce stereotypes about manufacturing by showcasing manufacturing careers as they are varied, well-paid, and rewarding. Then we will also like to promote gender balance in the manufacturing sector. As I said before, we see that women are underrepresented in this sector. And then enhance the responsiveness of educators, because they play an important role in this process of trying to encourage students to this kind of technical careers. Okay. Well, we have benefited from several synergies with other local organizations that are working also along the same lines. And some of the main results and insights of the project will be that we have been able to reach more than 4,000 students within these countries I have mentioned before. We have also created some digital learning content, namely, I think they are 7 nuggets and 3 learning paths for teachers training, because as I told you before, educators and teachers are a very important component in this project also. And we have had some partnership with the Skoda Auto, okay, and also with other smaller organizations that are working in the same field, okay. Mm-hmm. And here you have the contacts and the web page, and also some social media that we are currently working on as Instagram or LinkedIn. And thank you very much. We are open for your questions, of course.
Thanks a lot, Xavier. Thank you very much. It's very nice to see that you're also each one of the projects are also using the social networks also to promote the project, to spread the message, and to also to reinforce and communicate the results that you are achieving with your activity. So it's very nice to see that. This is also an activity that we want also to for supporting you in order to promote your projects and your results, and that's great that you are doing that. So thank you very much, Xavier, for the initiative. Looking forward for getting more and more results from you, and good luck for the next steps and the implementation of the initiative. Thanks a lot.
Thank you very much, Javier.
Thank you. Now let's go for the next project, the TF NoNet project, which is coordinated by LMS. And this time, yes, it's Fotios presenting the initiative, right?
It's indeed my time.
Thank you very much. Thanks a lot. And now the floor is yours for the presentation. Looking forward to listening to you. Thanks a lot.
Thank you for the very kind introduction, Javier. And hello, everyone. I'm Fotis Stamatopoulos. I'm a research engineer from Laboratory for Manufacturing System and Automation, located in Patras, Greece, at the University of Patras. And I will be presenting the Teaching Factory Knowledge Exchange Network project. So TNO NoNet for short is a project that is trying to address education, training, and upskilling in the manufacturing sector. So we are trying to nurture the next generation of engineers and also upskill and retrain the current workforce. How we do this, we need to involve both industry and academia to achieve this. The main issue that we see is that academia needs to be able to follow the industrial needs. So there is a really rapid change in engineering skills required in the past years, and we are not just talking about technical skills, but also business, innovation, and other soft skills. And the main issue with those skills is that we cannot effectively teach them in a typical classroom of a university. So this is the main issue we're addressing, that missing link between industry and academia and the achievement of not only technical, but other skills. How do we address this? We have created a network comprising of both academic and industrial partners that includes also bigger corporations and smaller SMEs. And we have created, let's say, 3 different types of pilots and work, 3 different modalities. Each one of them is focused on challenge-based learning. So the first modality is collaborative remote teaching between universities. There we have different academic partners from around Europe that we do joint lessons, and we do a project-based learning approach with students from different countries. So they normally design, manufacture a full product. They also check about marketing, life cycle analysis, and they do this in mixed multinational and multidiscipline teams. Secondly, we have another modality we call industrial challenges. There, students or young researchers solve real industrial challenges. So we have challenges coming directly from the industry. We contact SMEs or other organizations. They propose a challenge that is linked to their real needs. So they're trying to try out a new technology, for example. So they formulate this in a sort of a challenge, and then we have student groups or researcher groups working in teams, and they're trying to solve that challenge and then giving it back to the targeted SME, and they can try to implement it in the real world. And lastly, the third modality is training and upskilling, where we have our academic experts, our academic researchers, try and train and upskill industry employees. And in turn, we also gain from our side some valuable experience as well. And we always stay, let's say, in touch with the latest things going on in the industry. So both sides, both industry and academia, benefit. So what are the main results of our project so far? We have already completed or are underway to 10 pilot activities that are utilizing all the potential modalities, both the collaborative remote teaching, industrial challenges, training and upskilling. We have included 13 organizations, including some external companies. So we are 5 academic partners actually. We have an industrial association that provides some SMEs. We also attract some SMEs from our side. We have some bigger industries like Volvo Trucks, and we also have a lot of external SMEs. And what we have achieved so far is we had already 250 trainees from 14 different countries. That also includes students, researchers, academic staff, industrial employees. So everybody is working together through these different kind of pilots and try to exchange knowledge. So everybody benefits. Now, if you want to learn more about our project, the contact info is provided on the fact sheet. We will be able to answer every question also at the end of this presentation. That's everything from our side. Thank you very much.
Fantastic, Fotios. That was great knowing about the project and what you are doing. Tomorrow, in fact, we have the final of the Teaching Factories competition initiative that we started this year, which is very much related to this project and the Teaching Factories methodology. So we kindly invite everyone to attend and to participate in this session. So thanks a lot, Fotios, for the insights and looking forward to getting more news and more insights from your project in the next coming editions and the next coming events. Thanks a lot.
Thank you very much.
And now let's go for the last project of today, last but not least, which is the V-Machina project coordinated by SIA. And we have our colleague Enzo de les Cruz connected here today. Enzo, hello, good afternoon. Thank you very much. And really looking forward to listening to your presentation and the results from the V-Machina project, one of the great projects that we are also having as all the projects that we have had in this panel, but one great project that we want to know their insights and the outcomes that you're having with it. So thank you very much. Let's go. The floor is yours.
Hello, Javier. Thank you for the invitation. So nice to meet you, everyone. I'm Enzo de les Cruz, a French research engineer. And I'm today presenting to you the V-Machina 3 project, which is the third year of the V-Machina project. So the idea behind V-Machina is to provide VR trainings because due to the pandemics, some of the students in engineering school and more generally technical schools did not have access to industrial machine that can be very complex to manipulate, to interact with. And also some of the students may not have access to this machine in their school because they can be too expensive. So the idea behind V-Machina is to provide a VR-based training platform that is easy to use, that require no coding skills, that will allow you to develop VR-based training content. So the people working in this project are from 3 main entities. The first one is CEA. So this is the lab I am working in. We are providing the physics engine, which is here to make sure that the digital twin of this machine we add and we simulate is realistic and that it will behave the same way that it's behaving in the real world. We also have SUBC that has been in the project to develop a human activity recognition feature. This feature is required to analyze the student or the trainee emotion and attention to make sure that he's focused and he knows what he's been doing. And at the end, we have Light and Shadows, which is a French company focused on virtual reality that helped us to have 3D environment and 3D machine that are realistic, nice to look at and to interact with. So the solution we've been developing during these 3 years is based on Unity, which is a video game platform that require no coding skills. That means that a teacher could be able to create the content he finds useful for the students. So we are sure to provide to the teacher a tool that he will be able to use on its own and that won't require anyone to create a content on a pedagogical aspect he does not master. And everything that has been developed is connected to the Skills Move platform, which is a platform developed by the EIT Manufacturing that is based on Moodle, which is a standard protocol for any educational structure. So the outputs of this project and why we think that this is important are that we went to several schools all across Europe, in Slovakia and in Portugal. We made the content being tried by students from 12 to 30 years old. And for mainly all the students, they found it very easy to use, very realistic. And they were able to know the volume and the space and the precise element of the machine we've made them try them. The experience we've developed is multi-user friendly, so you can be 20 in the same room from all across Europe. It will be working perfectly fine. And we have lots of tools that are here to provide a score for the students to make sure that he did the steps correctly. Did the student ask for some helps? Did he skip some steps, etc.? And was the student happy or sad? Was it focused enough or not on the operation? So if you have any question, if you want to look at the content we've created, if you want to use the platform to create your own content, you will be able to find everything on the website we have, and you can find us on Google too. So
that's great, Enzo. So thank you very much. Thank you very much. They're really interesting and really very nice outputs and results that you're having with the project. So it's really it's really great looking at all of you. What are you creating? What are you doing? And what we are doing together, because EIT Manufacturing is done by every one of us. So we have, as a staff, you as participating in the projects, and that's what we are doing, creating a community of innovation and fostering this for the benefit of the European industry and the European society. And as mentioned before, to align that with the strategic agenda objectives that we have. That's great having you here, and so thank you very much. Thank you very much to all your project consortium, and looking forward to getting more and more information and results from your project. That's great. Thank you very much. And with this, we have reached more or less on time, so 2 o'clock. Now we move forward to the next session of the summit, which is starting right now with the second panel in the afternoon. So we invite you to follow the conversation and the interesting panel that we have right now. It was really a pleasure to moderate this session, to be with all of you. Thank you very much for the presentations. Thank you very much for attending, and thank you very much for being part of this great community, which is EIT Manufacturing. Looking forward to meeting you soon in next events and next sessions. And now please join us in the next parts of the session with the panel sessions and also the competitions that we have tomorrow for the RIS Leaders and a Teaching Factories competition. Thank you very much. Wishing all the best to all of you, and see you soon. Thank you very much. Bye-bye.
Thank you. Bye.